What's going on? This is SDG Laboratories. I'm Mr. Dalday. Alright. Look at all of these problems that I wrote up on the board. Let's start off with these things. All I want you to do is to predict the next number that's coming up. Hopefully you can see it. Alright, I've got x equals 0, 1, 2, 3, 4. What's the next number? Starts with an F. There we go, 5. Alright, here we go, 5.
Oh, that number.
That is horrible. I'm not used to writing backwards, alright? I'm used to just going 5. There we go. Alright. Predict the next number. You just walked in, so you're going to be put on the spot. It's not even hard, dude. Ready? 0, 2, 4, 6, 8. 10. The next one doesn't begin with who do we appreciate, alright? It's
11. 10.
Oh, come on, dude. 10. Alright, so it's 10. The next one, how'd you get that?
It's going by 2.
It's going by 2. So you just added 2 to get the next one. You can continue this pattern. I think that the word is nausea or something like that. Anyway, what is that? It's like
Indefinitely.
indefinitely, but I mean like agnosia or something like that. Which basically
You throw up.
until you throw up. I love that word. I saw it on an interview, like these guys from Guardians of the no, it was the Lego movie. We're watching the commentary. No, just pull up a chair right by Justice. We're watching the commentary, and they were like, you know that song, "Everything is a Fire." Those kids would sing it agnosia, which means until you vomit. All right, next one. I think this might be the next easiest one. Let's go. -2, -1, 0, 1, 2. 3. All right. 5, 10, 20, 40, 80?
160. They double it each time.
Okay. Huh. Yeah, let's go with that.
Am I wrong?
No, I'm just trying to think, like, how is that graph gonna look?
That would look really weird, actually.
It would look weird. I'm trying to think of it. Alright, whatever. Let's try this one. -2, -1, 0, 1, 2, 3. Alright, here we go. 11, 8, 5, 2, -1. Let's figure out the pattern here.
What?
11, 8. Leanne, I'm looking at you too. Go for it, Tejas. 94?
-4.
Oh, -4.
It's -3.
You guys got it?
She said she can't see
You can't see.
the black.
I can't see.
Oh, the
you.
black. Well, that's her fault. Her fault. Alright. -4. Okay. And you figured that out by, yeah, come on, pull up a seat. Is your last name Damas?
No.
No, okay, never mind.
He doesn't know his students.
What's that?
I said you don't know your students.
Absolutely not. Alright, sit down. Are you kidding me? Leanne's like, oh, thanks. Well, try this. Try grading a whole bunch of assignments for 3 classes and never getting to see anyone's face. How am I ever going to learn your names?
Only reason
I know
you
you
know
because
me.
you're always in trouble. All right.
Hey.
So what is the pattern here? We just subtracted 3, right? It goes 11, 8, 5, 2, -1, -4. The next one would be, if you need help, you can ask her.
He's putting you on the spot.
Yeah, well, you came in late, so
Um,
I don't even know what your name is.
Randy.
Oh, hey, how's it going, Randy? I'm Mr. Dalday.
-3.
No,
Wait, what's the?
you wait.
Negative.
Okay, go. You can answer.
-7.
-7, absolutely. You seriously let her ask you, and then you told her the wrong answer, and then you raised your hand because you knew the right answer?
That's dirty.
That's
That's
dirty. Dang. All right. Anyway, let's try this one. Ready? Let's try this one. 0, 1, 2, 3, 4. The next one would be 5. Okay. And let's go 5 halves, 2, 3 halves, 1, 1 half. What is it?
What's what?
The next one.
5.
Oh.
Here, I'll give you a hint. It's actually
0.
0 halves. Yeah, that's absolutely right.
Oh.
I mean, if you look at this, 5 halves, 2 is the same as 4 halves, right? 4 halves is the same as 2? That's horrible, I'm sorry. 4 halves. 1 is the same as 2 halves. So look at it, 5 halves, 4 halves, 3 halves, 2 halves, 1 half. You're right, 0 halves. 0 halves is the same as 0. 0. You're just going down by a half. We cool? You good? All right, the reason why it tripped me out with this one right here is because where is that on? Oh, that's part number C. All right, the reason why that one tripped me out is because with these ones, you added a constant number, 2, 4, 6, 8, 10. You subtracted a constant number. You subtracted half by each time. Does that make sense? We subtracted 3 by each time. This one, we didn't add a specific thing each time.
Didn't we? I mean, there we doubled it, and there we doubled it.
We didn't double it, we just added 2.
Oh,
I can see how you mean double it. You
yeah.
mean double this number. 3 times 2 is
Yeah.
6, 4 times 8 is, or 4 times 2 is 8, 5 times 2 is 10. You can kind of even think of the same pattern over here. Like for example, actually, I can think of the pattern. I'll show you guys how to think of the pattern or how to come up with the equation to relate these two numbers together. But you can kind of see the pattern, okay? The reason why I think this one's interesting is because these are called linear functions. What are linear functions? Well, you know what a function is, right? I mean, I've been beating that to death, right? So a linear function would be, all right, what does the word linear make you feel like?
Bored.
A board? Why? Why bored?
Because it's just a line.
A line, there we go, that's what I was looking for. Yes, and I agree with you, lines can be boring, but I'm gonna make them interesting because we're gonna spend the next, like 4 weeks, 5 weeks on lines. They are actually really interesting and we can get it to be very, not complicated, but very in-depth. All right, and that's what we're gonna explore. But yes, we're exploring linear functions. This is a linear function, this is a linear function, this is a linear function. My computer just died, I guess, and then this is not a linear function. If you were to graph this, I would graph, it would go x equals 0, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. And then it would be a line. Agreed? If you were to graph this, is this going to be a line? Well, I just told you it would be a linear function, but let's try to figure out what the graph looks like. And of course, I'm not drawing the super pretty graph, I'm drawing the super ugly graph, but let's try it. All right, let's go. -1, -2, 0, 1, 2, 3. This goes up to 11. Let's see, it's somewhere around there. So this is what, 5, 10, here's 11. This goes up to 8, so that would be maybe around here. This goes up to 5, around there, I would say. There we go. This goes up to 2, maybe somewhere around here. This goes down to -1 over here. This one's going down to -4. Look, it is a line that I totally missed, didn't I? There we go, it's a line. It's a line that's going down, right? So can you guys see the pattern and how that works? This one, on the other hand, it isn't a line. That one is probably going to describe some kind of curve, I'm thinking, to be honest with you.
So,
Which actually surprised me because I didn't think that that would be, you know, the pattern for that, but whatever. All right, here we go.
it's not a problem.
Oh, hey, I started talking to you about the different graphs and they actually asked questions. All right. Actually, all of these questions I already asked you, so we're good. And it says over here, it says graph them. Oh, we just graphed them. We're done. All right. Important property of a linear function. All right, let's read this. The definition. A function is called a linear function if the output of the linear function changes a constant amount as the input changes. That's exactly what we're describing here, right? That's the technical lingo, right? But you understand what I'm talking about here? It's saying as this x changes, this y is changing by a constant amount. This thing is changing by 2. By 2, by 2, by 2. This thing is changing by -1/2. Down by half, down by half, down by half, down by half. This thing's changing by 3, the constant value 3. Down by 3, down by 3, down by 3. This, on the other hand, is not changing by 10. The next one should be 15. No, it's not 15, it's 20. Next one should be, 20. No, it's 40. You know what I mean? So it's kind of, this one is not a linear function.
Oh, it's not.
Yeah, because it's not changing by a constant amount. That's what it says. The output of a linear function changes
So
a
doubling-
constant amount as the input changes. So the
doubling
input's
doesn't
changing.
count as constant.
Well, it's not. You're not changing it by a constant amount.
Okay.
You're changing this by 5, right? To go from here to here. But then you're changing this amount by 10.
Right.
You know what I mean? Which is kind of a weirder function. So that one's not a linear function. That's all I wanted to do is make sure that you're able to identify linear functions. Shoots, bro. Up out.